if you've used CPU or CPU Freak, any of these frameworks, obviously we have a lot of vested interest in these frameworks. We have maintainers working for us who maintain these frameworks. We have a lot of contributions here. It's the same with the tools. So we've created tools for our own analysis. We've created tools for our own functional testing to make sure that PMQA. So whether we have the right power management functionality on a vendor platform for us to be able to do anything useful. And we've put it all out there. So I mean, these are things we create for our own use, but then we put it out there to see if members have found it useful. And in most cases, they have. So we've done a bunch of work around improving CPU wake-ups or minimizing CPU wake-ups. So we've done work around no hertz. We've done work around work queues, power efficient work queues, and dynamic hierarchy affinity. So these are things which I've noticed. All of this work is in mainline, by the way. And some vendors are using it. Maybe others are not aware of it. So this was another way of, and these were smaller projects inside PMWG, and so not a whole lot of weightage goes into it when writing up reports and in all the member reports. So this was another way of drawing attention to these to this kind of work. And then yeah, hibernation. We've upstreamed core support for hibernation on ARM. We've done some work around adding frequency capping for thermal cooling, which ARM is now taking into the next level with their work on IPA. So, actually, I'll just try this. So yeah, and if you're using any of this work done in the last couple of years, this is a significant amount of work that we've done in Linaro, in the Linaro Management Working Group. If you aren't using any of this and you're interested, come down to us. We'll be happy to get you to work with them. We're also talking to the LSK team, Mark Brown, to see which of these makes sense to be backported. Some of these patches could be backported into LSK for your use. So we're working with them as well. So the team currently with 12 people plus myself, 6 of which are assignees. We have assignees from our member companies. We have one from Huawei, 2 Qualcomm, 2 MediaTek, and 1 ST at this point. We have in the room 1 more MediaTek assignee, which even my team doesn't know is a new assignee who's going to join very soon. So freedom right there. Scattered all over the world. So there's a lot of time zones there. And one of the things that has been important inside the PMWG is being able to maintain these going forward, maintaining some of the key components of power management going forward. So all these guys are, some of these guys are maintainers of these key subsystems we care about. So CPU idle, RMSoC, clock framework, MMC, clock events. We also have now working for us at Linaro as CPU Freak maintainer as well. So these are things that we feel is good investment to control control our own destinies in a sense. I mean, as the ARM ecosystem. So I'll finally get to the meat of the topic, which is the lightning talks itself. So that's the order really. I'll go first. Yeah, I'm tech lead. I manage activities. If you ask me where I live, the next time the answer might not be the same. So that's just in the last year and a half. And that's not my home, by the way, but it's a nice picture I found in Bangalore, in villages of Bangalore. So one of the key things from me personally is to hear from members about hacks they have to put in place in the power management frameworks to get things to work on a product quality solution. So if you have to work around frameworks, this is something that PMWG is meant to solve. So come talk to us about that, and we'll find ways to solve those problems for you. Yeah, I mean, during this, so what I'm going to do is basically hand over the mic to each of my engineers who are going to talk a little bit about what they're doing at Linaro. Most of us wear multiple hats. Some are maintainers, but they're also working on other pet projects, part-time projects, whatever. So they'll just talk about it. And feel free to ask questions, interrupt us in the middle. Let's move the next.
Good morning, everyone. I'm Tuukka Tikkanen, and I'm assigned to Power Management Working Group from Huawei. I live in Tampere, Finland, and the Huawei office where I'm supposed to, or where I'm located, it's 100 miles, so that's a bit of a commute. So actually, most of the time I'm working from home. Sometimes I have to do this wonderful, wonderful 100-mile commute. In the Power Management Group, currently I'm working on our big task, which is working in collaboration with and the other folks to come up with the energy-aware scheduler, which is the thing that you will be hearing a lot about today and all of the week. And in particular, the exact field I'm working in is integration of CPU rec, or actually it's part of actually replacing the governors with EAS implementation. So what we are doing right now is we are creating a system whereby the scheduler will indicate what the desired capacity of the CPU should be, and in the future the EAS will be giving this. But when we do this much simpler implementation, it will pave the way for the unified EAS implementation. As a person, I'm quite simple. There are not many things in my life, so if you want to talk something other than shop talk, you can talk to me about pinball games. Actually, on this trip, I will be bringing back something like 5 kilos of pinball parts to Finland, so I can maintain my pinball games. I have 3 at home. And if you want to talk shop, I've spent quite many years thinking about the selection of idle states. So when you have no tasks to run, there's a number of states you can go into, and choosing one, it's not so simple, especially if you have multiple cores and there might be dependencies between these cores. And yeah, one of my favorite hobbies, if it's like not work but computers, I like to do everything with FPGAs if it's hardware. So I could buy a $5 microcontroller and do something, but instead of that, I usually prefer to do FPGA because it's so nice to try it VHDL. Okay, thank you.
Let's get next.
Hello, hello. My name is Kevin. I am based. I also work from my home. I think most of us do. I work from my home in Seattle, so I had one of the shorter flights here for this week. I work for Linaro. I'm an employee of Linaro, and I work on a lot of things related to kind of the core power management frameworks. So I'm particularly interested in the suspend resume kind of core, runtime PM core, CPU idle, CPU free core, all those things. And in particular, I'm very interested in a lot of the ways that people are putting these together. So if you, a lot of people, I like to review what people are doing with these frameworks, and a lot of people put them together in clever and interesting and sometimes not very clever ways. And so if you have ideas of how these work together or how they should work together better, I'd love to talk to you as well. So I've looked at quite a few different ways of implementing these frameworks. So I also, it's not exactly related to this team, but in one of my previous lives, I was maintaining the OMAP, the TI OMAP power management infrastructure, so I quite a few TI boards, and so I kind of automated a bunch of tests for those. And then once I started working for Linaro, I added a couple boards and started publishing kind of automated boot tests for these. And as I did that, people liked what I was doing and just started sending me boards. So now I'm up to about 40 boards in my small backyard office that's running every time there's a new mainline Linux Next stable or LSK kernel. It actually boots across all these different ARM boards, and I email out a report to to that. So that's kind of become a little bit of a side project. I'm also working on kind of the basic support for the Chromebook 2 platform that our team is kind of using as a reference big little platform. So making sure the infrastructure pieces for that platform are upstream. I'm helping as kind of a backup maintainer with Arne Bergman and Olaf Johansson, who are maintaining the ARM SoC stuff upstream. I'm helping kind of step in there when needed, and I guess I'm not actively working on this anymore, but I helped get kind of the no hertz, the full tickless stuff upstream for ARM and ARM64. So I guess that's kind of the bulk of what I'm doing for Linaro. Who's next? Larry.
Hello. So I work for Qualcomm, and I'm sorry. I had an even shorter trip here, so I drove from San Diego up here. It was a nice drive. I'm going to take a vacation on the way back, a lot slower of a drive. And unlike Tuka, I have a very short commute to work, so I spend about half of my time working from home and about half of my time working from the office 5 miles away that Steve works at. And I've been working with computers since before many of you were born. I remember punch cards on an IBM mainframe in 1974. I remember loading PDP 8s, I think, on paper tape, booting BSD 2.9 Unix in 1980, and I've been working with Unix and then Linux pretty much ever since then. So I love working with the Linux kernel and any other Linux stuff that is user space that's related to it. At Linaro so far, I've been working on, my first project was to extend a lot of the work that Kevin had been doing on no hertz, and I did ARM64 contracts tracker work, which was my first Linaro submission upstream, and it's in 3.17 from what I understand. And idlestat, I've been writing code to deal with energy model, and the first web has been written, and I've gotten a bunch of new code from ARM that needs to be, I've looked at it, the best of it needs to be put into our tree. I'll probably be doing some of that work here, in fact. And I've been also working again with Kevin on some of the getting Chromebook 2 working. Eventually I will be playing with the EAS kernel on Chromebook 2 and tweaking it and fixing it and doing things of that sort. In terms of things, my hobbies, I do number theory research. I used to be, if anybody's heard of it, one of the judges of the obfuscated C code contest many years ago. I also, many years ago, liked playing pinball, 1970s era pinball machines, and also interested in things like the stock market and sports like baseball and football. Sorry about the Seahawks, the Chargers beat them yesterday, etc. So, okay.
Hello everyone. I just been told to give a talk a few minutes ago.
You didn't read your email.
I come from MediaTek in Taiwan, and my previous working experience mostly about kernel porting and driver development for our chip. I've been in Linaro Connect for several times, but this is the first time I stand here and talk. I feel good. What I'm doing now in Power Management Group is energy-aware scheduling and kernel upstreaming. My habit is I write here electronic guitar. And I also write autos from scratch. So if anyone have habits, stand with me. We can talk in private. That's it.
Hey everyone. Yeah, so I'm Mike, that's me. And I'm right now, I'm based in Los Angeles, but I kind of like Ahmed, I move around a lot, my wife and I. So we just moved to Los Angeles, but maybe next year's Connect, it'll be a different story. Coming to San Francisco is cool because we used to live here as well. So it's like coming back home. At Linaro, I maintain the Common Clock framework, and that's more of a recent framework. I guess it was merged in 3.4, and lots of people in here have submitted patches or somehow been involved in stuff like that. It's maybe getting time to rewrite parts of it. I was told the USB subsystem was rewritten 3 times in the kernel, so I'm wondering if it's time for Clock Framework version 2. Maybe we can talk about that while we're here. Mostly what I'm concerned about these days is the energy-aware scheduling stuff. Along with Tuka, I'm involved with the CPU frequent scheduler integration. And so this Connect has got really interesting timing because there's but there's definitely some patches that that it's just now time to really start looking at them. So there'll be a lot of over-the-shoulder patch review while we're here, and hopefully some patches in the list during this week as well. And my interests are similar to what others have said. CPU freak, dev freak, a lot of the core power management frameworks. I spent some time shipping Android devices at a semiconductor manufacturer. So I've done all the same crazy hacks as the rest of you. And like Amit was saying, it's interesting to know what hacks are being done today. Maybe we can get rid of those hacks and replace it with some useful infrastructure instead. And then I maintain a second-tier board farm compared to Kevin and Ola. So not near as many boards. And what I'm trying to build right now, what I mostly have working, is a power regression testing suite. I really would like to solicit feedback from you guys as much as possible. The general idea right now is for every major kernel release and maybe for every RC tag that comes out, for all the boards that I have, run some workloads, get some power tests, and then basically test regressions as a percentage of energy consumed change. So it's not publishing power numbers. You guys don't have to worry about secret numbers being released that anyone can measure. But instead, sort of seeing if through the course of all the RC cycles, if we're seeing any regressions with respect to energy consumption. So if you guys want to donate boards to that, or if you just want to talk about the right way to do that, what kind of measurements you're interested in seeing, I'd be really happy to talk about that as well. And there's some other interest there at the bottom, so feel free to just say hi.
Hi, I'm Lina. I've been working with Qualcomm for a few years now, and I'm a Linaro assignee. I focus on CPU, power, and thermal management, and of late I've been focusing on upstreaming many of our drivers and many of the changes that we made for production devices. And so there are quite a lot of hacks that we've done, and with Amit's help, we're going to get many of these hacks upstream. So that's pretty much it, and I guess there are a few other interests other than just work. I like to road bike and just talk about science.
Hi, my name is Daniel. I'm based in France, in Toulouse. It's a nice city where they built the A380 Airbus plane. So I'm a Linaro employer since 3 years now. I began as an assignee from IBM, and I worked 1 year with IBM on site Linaro, and then I joined Linaro, and I'm working since 2 years as a Linaro employee. My experience is I'm doing kernel hacking since more or less 10 years. I began with upstreaming the Linux containers technology inside the kernel. So it was a big work, and especially the network part. Now this Linux container is known as LC. And little by little, I have been involved in board management, and now I'm maintaining the CPU header framework for ARM. Mostly the work I done the last 2 years was to clean up all the drivers and try to unify these drivers to have the same scheme for all these drivers, and split the PM specific code and move this code inside the Arch directory, and just put the backend driver more less Arch specific, in order to be able to merge all these drivers, so that reached the point where today we are able to define the different idle states with the device tree, and so we have now a generic driver. We have just finished, and we are merging upstream. Beside that, I'm also maintaining the clock events. So the clock events drivers and the clock source drivers are important because they are a source of wake-ups for the system. If they are not implemented in the right way, they can lead to a lot of wake-ups for the system, so for less efficiency. So it's interesting to have an eye on what's happening on these drivers. Mainly today I'm working on the energy-aware scheduler and trying to integrate the CPU header framework logic from the CPU inside the scheduler, so we can be more efficient and more smart when we choose the idle state we will go. And so part of this integration is already upstream, is mostly code reorganization and storing information inside the scheduler to be accessible directly for it. Today I'm also working on the I/O latency, investigating more than working on, but creating some kind of proof of concept with an I/O latency tracking mechanism. So the idea is to track the different latencies for the per task. So when the scheduler knows is going to switch the idle task because there is nothing left in the system, because some of the tasks are blocked on the IOs, we can, with some heuristics or some kind of load, deduce what will be the next event on the system based on the IO to wake up the CPU. So we are more efficient in the decision. We should be more efficient in the decision. So today we are investigating that, and well, there is a prototype available in the JIT tree for the integration tree, for the energy-aware scheduler integration tree. And also, I like to make the Linux better, so to send some cleanups and unify the code across different subsystems when that's relevant. So if you need some helps on these areas, CPU idle or management, some part of the scheduler, you can ask me. And also I have a strong experience for system programming from user space. So if you need advices, for example, to develop an application in user space to be less more energy efficient, so you can also ask me.
Hi, my name is Pichon, and I'm assigned into this group from MediaTek, and I live in Hsinchu, Taiwan now. I have some experiences working on loader, driver, kernel porting, and PSP maintenance. And for Linaro, I just joined this group as an assignee for less than 2 months. So I'm just now doing some simple stuffs, like some allostate fixing, and I'm now also starting to do something in the car framework. And my interest is to trace and test Linux kernel code to understand how those how every subsystem could work with each other. So that's all. Thank you.
Okay, I'm Ulf. I'm a Swedish guy, and I live in a small town in the south of Sweden, Trelleborg, and normally I drive by car 50 kilometers to a small Linaro office that we have in Lund, where I meet up with the other Linaro Swedes. Yeah, I have a family with 2 small kids back home. And in Linaro, I have kind of 2 parts that I'm involved with. Maintaining MMC subsystem, and well, all that has that comes with maintaining that subsystem. Especially what I haven't contributed to the MMC subsystem is the power management parts. So I guess that's why it fits in to this area as well. And what I've been working on recently and the past half year is something that I call one-time PM deployment for OnSoc. To summarize it a bit, I think it's one of those things that has been missing framework-wise, PM core-wise, for various SOCs, and I'm trying to find out the missing pieces that's, to make this work for a complete SOC. So that is also related to how power domains and stuff is being used. That's what I've been doing. So it's more on a framework level, I would say. So I'm not that deeply involved with like some of the other guys with energy aware scheduling. That's not my plate, cup of tea. Not yet, at least. Soon, yeah, maybe. Yeah, and I like skiing, sports, food, beer, whatever. Okay, thanks.
Right behind you. So most of when I work from home in Seattle, Washington, but I occasionally visit the Linaro C office, aka Kevin's backyard shed. I was over for Linaro, and pretty much what you'll notice on the slide is like the main work I do is testing related. So I'm co-maintainer of the PMWG test suite, working on this month's monthly release during Connect. And then I also get the chance to interact with other teams and see what they do and try and learn from them, especially the Lava and QA teams. You know, just sure the Lava guys are, you know, happy to hear me all the time. And other than that, I'll be happy to talk to everyone about my experiences as a Linaro's first junior engineer. I'll be reaching my 1-year mark this November, actually, and then actually did skydiving during my last vacation. So it's, you know, something to do about once in your lifetime. And I'm going to hand it over to Vincent. I think he's next. Yes.
Hello, so my name is Vincent. I'm nursing in the power management working group for estimate production, and I'm based in Le Mans, France. What I'm doing in PMWG is mainly working on the energy aware, energy efficient scheduling for maybe 2 years now. And more generally in all areas in the kernel that make let's say a difference in the power consumption. So I look at the work you for a while ago. Also it's different, but now the scheduler is the main issue that we have to solve. So yeah, I'm working right now in rework on the consolidation around the CPU capacity in the scheduler, and more generally on tracking all the unexpected wake up or event that just wastes energy on the platform. And for that, I'm mainly using the Chromebook tool and its Hyatt core. So you can talk to me about landscaping if you want, but more generally, any improvement in the power management of a platform and embedded platform, and mainly where to place any task or thread on the platform.
So that was the current power management team, what we've been doing. And these are the highlights of what is in flight, what we are working currently on. So you've heard EAS being bandied around many times now. I think about 5-6 people on the team are now working on EAS, different aspects of EAS, core scheduler, tooling, validation, and we're going to ramp that up a little bit. We've got some changes around clock framework that Mike and Bicheng are going to be working on this week. Lena has been working on improving PMWG framework to become per CPU. Currently, it's a global constraint. Wolf has just mentioned the idea of creating a reference runtime PM implementation. So runtime PM has been in the kernel for a very long time, but very few people still use it as part of their BSPs. We want to try and change that by creating a reference implementation upstream, so that more and more of our members and vendors start converting their drivers over there. And around rules, there's going to be a bunch of work done around improving reporting and adding new features around energy model. So this is a snapshot of what we, as a team, we're working on upstream at this point. Plans for the week. Sorry. That's a picture from the tall ships races that happens in the Baltics. So it goes across Finland, Estonia, Sweden. I think great ships there.
So we will be sailing or smoking or both?
Yeah. So yeah, the plans for the week. So tomorrow we have a session around analyzing scheduling behavior and its impact on runtime power management. So some of the tools we've created, ISTAT, RTApp, to try and figure out these problems. Then there's the EAS workshop on Thursday. So that's all morning on Thursday. We have 3 sessions where the engineers are going to be talking about what happened at the Tunnel Summit. And then one of our members are going to be talking about their own EAS implementation and what are the pitfalls they had to face there. And finally, our plan going forward. So we've made some progress and then basically try to identify what the next steps are. In between this, we are also going to be doing a lot of hacking sessions in the afternoon, where we are going to be trying to try and figure out what the next steps are for EAS specifically, and then there's several other topics around runtime PM, platform enablement. For example, you've heard a lot of people are using the Chromebook at this point for development because it's available, it's got good mainline support, and it seems to be the most usable platform. If you have a platform, as a member, if you have a platform that would be more useful to share with us, please come and talk to us. Please come and talk to me, and we'll see how we can work that into our testing and validation At this point, we feel that between ARMS Juno, once the power management bits are available, and the Chromebook, I think that those are our two best bets to make progress on the core infrastructure work. Yeah, so there's going to be several, so SAN AA, that's the room to find us in the afternoons. So come talk to us there, any of the engineers, if you want to talk about specifics. And we're going to be hacking on several things. There's going to be discussions around EAS, obviously, around some of the tools and infrastructure. So please come and talk to us. These are some of the resources mentioned in the slide. So if you're interested in some of the tools we've created, go have a look there. There's some charities, some of the work we've done upstream. If you want to see if your platform support that. That's about it from us. Do you have any questions?
Sort of generic question, there is some sort of dinner placeholder that's been defined yet as to where we're going?
Yeah, you'll see email about it later today.
So VM changes for HTTP enabled platforms with non-knowledge group. I haven't heard that term.
So that's being spearheaded by LEG at this point, right? I mean, the CPBC driver that you guys are working on. We expect to be involved in the review process. I've talked to Andrea about it, and I think we should definitely be reviewing the code. But because we don't have access to the platforms at this point, we are not involved in the development directly. Access to hardware platforms has been a challenge for us, and so if that can be fixed, we can we can increase our participation.
So how do you see those converging, and what this group is doing versus?
So I guess I need to just sit down with Andrea and try to figure out where we can actually provide most value. I feel at this point the most value we can provide is actually reviewing all that code. We have maintainers here for CPU idle, CPU fake, and so I think that's the best value we can add at this point. But if there's more engagement needed, we should definitely talk.
And there's another topic that you mentioned, some test benches for PM code. Where do I get more information on that?
Right there. Okay. So you can download the slides there. So there's Git trees right there. Actually, I left out RTApp. RTApp. So we've used RTApp to create a workload generator as well. So if you're interested in any of that, please go ahead.
Thanks.
But yeah, you should find RTApp in a similar URL. So it will be the same URL, git.linaro.org/power and then /RTApp.
Yeah, question here, sorry.
Hey.
For those of us just getting introduced to EAS and looking into this on Big Little HMP, is there some kind of overview presentation or something we could, from you guys at Linaro, or we could use to get introduced, or at least understand what are your main goals and what main projects you'll be working towards features?
Martin, are you going to cover that in brief on Thursday?
Yeah, I'm going to give a short introduction.
Yeah, so go to the EAS workshop on Thursday.
Thanks.
I'm not sure you have time. Could you talk a little bit more about hibernation? What does, kind of really has any like ASIC hardware platform dependency with more abstraction?
So with hibernation, we've got this question from a few members. What we've done is we've upstreamed the core support for hibernation on ARM. So everything around saving of the pages and into an image and all that. What individual SOC vendors need to do though is add the platform hooks. So that's very vendor specific. We haven't done that. We tested the implementation on a TI BeagleBone platform, and it works there. The key requirements for Hibernation to work on your platform is first to have suspended zoom working. That's a key requirement. And beyond that, then you need some sort of support from your firmware. I mean, when you're booting up, to be able to restore from your image, the hibernated image, instead of doing a fresh boot. But all of this is actually very, very platform specific. And so we are not planning to do any work around that, around doing a reference implementation at this point, because it requires extensive knowledge of the platform. It requires all the drivers to support suspended zoom. But we are willing to talk to you about how to go about doing it, how to reach that point, because we know how to get there. It's just that we don't have the all the documentation available for the SOC to actually go and do a reference implementation.
I think one of the things like so I mean, you go to hibernation, you want to wake up as fast as possible, right? So you could save something and you restore things like that. And so what do you save and then how do you restore? What are the things you can do in terms of if you want to boot up as fast as possible, you want to bypass or shortcut some of the things. I don't know, is there something that...
So you're talking about hibernation as a alternative to fresh booting, so that you can restore quickly, right?
You want to go the lowest power as possible, so you want to power as much as possible.
Mm-hmm.
So and then there's a trade-off, how much you want to save. You can still save something so that we can come up as fast as possible. Right? That's the thing. Do you have any kind of...
I'm sorry, I didn't get the question really.
I mean, like hibernation related to you have to go in hibernation and wake up, right?
Yes.
So then it's part of the same thing. You have to wake up, right? How you handle that? Is that part of your this hibernation, whatever you guys are doing?
So how do you wake up? As in, so wake up source?
I mean, in terms of you go to hibernation, right? You have to wake up, right? And when you wake up, what do you do?
Yeah. So some of that is in the firmware, right? Your firmware decides what to do, whether you want to boot the CPU and do a fresh boot, or you want to just point to an image that you stored earlier, a hibernation image. And so I think the BeagleBone was the only platform where we would actually get it to work correctly, because the firmware had the right hooks in there. We don't have enough information about other platforms, to be honest, because it's all in the firmware. Kevin, do you know anything about other platforms that have this support?
There's a lot of platforms that claim that they do it out of tree, and products that seem to be probably using it, but I don't know any of the ones that are upstream. The TomTom guys who initially started this work, they have platforms that are doing it as well. So it's out there. The other thing I was just going to add, though, is that there's potentially for what you're talking about, faster wake-ups, or deciding whether you want to wake up really fast. There's driver work that can be done too, because the PM core provides you hooks for suspend and resume, but you also get some additional hooks for hibernation called freeze. You can choose to use those or not to use those depending on optimizations you might want to do for specific drivers. So there's a lot of platform-specific optimization that can be done on that too, and that's where it gets, when you're talking about a reference platform, that's where it gets a little bit, that's where it gets very platform-specific.
So hibernation. Hello. So hibernation was one of those things where a couple of members asked us to do this work, say about a year ago. After that, no members have really expressed an interest in continuing this work and adding more features or anything. if something like that is required, then I expect you should go talk to the DSC and basically raise this as a request so Linaro could look into it.
About the firmware aspect, you know this already, Amit, but for other people here who perhaps haven't heard, let's try to socialize an interface standard to help clearly define what are the partitions and the roles and responsibilities of the secure side and the non-secure side. To pull things off, like system suspend, for example, it's called PSCI. It came a bit late to the party, all said and done, but we're trying to get partners trying to look at it as a reference in order to get the hooks that you mentioned in place. So that's sort of helping with this.
So would Juno be a good reference platform to implement hibernation?
Yes. So the PSCI hooks are actually enabled doing full system suspend, which is part of the hibernate strategy. It's supported by PSCI and PMWG. We are on the hook to make sure that it's actually available and gets exercised in a complete way for Android actually on Juno. It's one of the things that you and I also discussed this week. So PSCI spec is available if people want to look at it and understand how the strategy and division of responsibility is supposed to work.
So this question has been asked quite a bit, the question about hibernation and having an implementation. So if we can actually provide a reference implementation even on Juno, I think would be something valuable for users.
For Juno, ARM also provides the trusted firmware, and that has a reference implementation as of 0.4 for Juno. I'm not exactly sure if it includes hibernation, but it has a demo.
We're on the hook, we're on the hook to make sure that there is an implementation and it's tested with Android.
Have you guys actually done the work to add core hibernation support to ARM64?
It's on the cards. It's going to happen very soon.
Okay, so something similar to what we did for ARM32 has to be done for ARM64 first. So yeah, there.
Actually, it was interesting to see the decision with PSCI. PSCI itself is not aware of the system level states, right? Or is certainly changed. That's coming this time.
Yeah.
PSCI is giving you the interface level story, right? So here's what you need to do to power off CPU when you back in. It's not talking about the specific states of open by system. That's an implementation specific thing. It would have been great if we actually had that nailed down on the design. So what can we do?
So I can't say for hibernation, but at least for suspend for idle states, we've got the infrastructure now or going upstream and we're into foot. So presumably for hibernation states, if we need to know bits of information about those states, we describe those in DT or ACI or whatever. Yeah. So PSCI is just the calling convention and the interface and all that, and any particular information you need about your platform you describe in there. There's some magic numbers for you to answer.
I think initially there was some plans to do some hibernate, but in reality, the bringing up and development for Juno dragged for so long that some of the stuff is basically falling off the edge. Probably good opportunity for Linaro to step in.
Yeah, so my understanding was we don't yet have the full interface or that would be required for hibernation described in the PSCI spec, but it is being worked on. I'm not sure if Charles is around to discuss that or not. Okay. Yeah. So he's the guy to talk to on that.
Yeah, it's certainly something. I mean, the core support for ARM64 could be something that Linaro could definitely look at. You guys are already doing the driver work and all the PSCI work on Juno, so it should be possible.
we have made public the kernel and the trusted firmware. So it's not entirely just Linaro. Yeah, anyone could pick up the work and can do it. If Linaro does it, they know how to get in touch with us and tell us. So we avoid duplication.
So, excuse me, one moment, last one, I guess. So I'm curious about the PCI suspended implementation. Maybe there is a hackathon that, I guess, a feedback session there. Would be interested to find out how the, I guess, high-level state information is being supplied to PCI.
You want to look out for this gentleman called Charles Garcia-Tobin. He's arriving tomorrow. Okay. So you want to look out for Charles. Come to San Pablo A, and you'll find him there.
Tomorrow?
Yes. Well, tomorrow, right? Yeah. You should definitely connect to Charles on that.
At least for the idle states rather than the load balance suspended regime states. That's on the main list of patches.
I think we're out of time.
So there's another interesting feature that I'd be interested in talking to anybody who's using it. Relatively recently in the kernel part of the PM core added a new feature that's, I don't know exactly what they're supposed to call it, but Raphael basically calls it suspend idle, and the code calls it PM suspend freeze. But the basic idea is you mostly suspend user space, you suspend all the drivers, and then the CPU idle basically just kicks in, the CPUs remain active. So it's essentially it's a suspend idle, I guess is a good term for it. But if any of you have interesting use cases or ideas for that, it's not terribly widely used. It's relatively recently added to the kernel. But if for anybody who has ideas about that, I'd love to hear your ideas of how you might use that, or ideas for faster wake-ups or something like that you might have around that. So let me know. We're out of time.
Yeah, we are out of time.
Okay.
Thank you.